Hello, everybody, and welcome back. Mr. Lake here with another chemistry lecture video. Today, we're going to start talking about chemical reactions. So far, we've really focused a lot on atoms. Pretty much all of Chemistry A was focused on atoms and their internal workings and what they're made of and all those subatomic particles and what they all do. And then, so far in Chemistry B, we've been starting to think about, okay, what happens when atoms come together and they form compounds? How do we write names and formulas for those things? How does that work? How do atoms actually bond together in different ways? Now we're going to start getting into what do the processes look like where that happens, where atoms come together to form compounds, or maybe where compounds break apart into atoms, or maybe where multiple compounds react and atoms kind of switch around and rearrange. So we're talking about chemical reactions today. And the first thing you need to know is just how to write chemical reactions. You've seen chemical reactions before. This is probably not going to seem like something completely new, but we also haven't formally talked about the nuances of writing chemical reactions. So first of all, what is a chemical reaction? Well, it is a process by which one or more substances are rearranged to form new substances. So, like I said a second ago, it could be a couple of different elements, a couple of different samples of atoms coming together to form a compound. It could be a compound breaking apart. It could be multiple compounds reacting with each other and things getting rearranged. Notice, it doesn't say anything about substances being created or destroyed, because remember, that doesn't happen. The law of conservation of mass is still followed in all chemical reactions. So atoms are never made from nothing. Atoms are never destroyed. Atoms can simply kind of change form, switch what they're bonded to, or switch with their charges, or whatever. Now, when you write a chemical reaction, um, the basic structure is what you see along the bottom here. There's essentially a left side and a right side. The left side is called the reactants, and those are the starting substances. They are the things that go into the reaction. They are the things that react, which is why they're called the reactants. On the right-hand side are the products. Those are the things that are formed in the reaction. In other words, on the left-hand side is the before, and on the right-hand side is the after. They are always separated by an arrow, so that's where this is different than a mathematical equation. In a mathematical equation, you'd use an equal sign. In a chemical reaction equation, you use an arrow to say that this stuff turns into this stuff. Sometimes the arrow can be double-ended, meaning there's an arrow on both sides, and that just says that the reaction is reversible. It could either go from right to left or left to right. We're not going to deal with a lot of that in this class, but it's something good to know about. And you'll notice that if there are multiple reactants, they're separated by plus signs. And if there are multiple products, they're separated by plus signs, just to say that the SO2 is something different than the O2. Those two different things come together and they produce the SO3 product. Now you also notice that there are numbers, coefficients, in front of some of these chemical compounds. So those are called coefficients, and they represent how many of each reactant or product are involved in a single instance of the reaction. So what this means is that 2 molecules of SO2 react with 1 molecule of O2 in order to form 2 molecules of SO3. These coefficients are going to make a lot more sense in the next video when I talk about balancing chemical reactions, but I want to introduce the concept of coefficients just as part of chemical reactions here. And also, again, chemists are lazy. We've talked about this a number of different times. And when there's a 1, chemists just don't write it. So if you have a 1 charge, you don't write the 1, you just write plus or minus. If you have a 1 subscript, you just don't write the subscript. And if you have a 1 coefficient, you just don't write it. So there's no coefficient in front of the O2 in this equation. That doesn't mean that there's no O2. It just means there's only one of them. So you only write a coefficient if it's 2 or more. Now, some other things that you'll see, we already talked about the plus signs, we already talked about the arrows. This is what a double-ended arrow would look like that says that the reaction is reversible. You'll also notice that there's little like letters written in parentheses as subscript after the reactants and products. Those indicate the state of matter. So you won't always have these, especially if you don't know what the state of matter is. But if you do know what the state of matter is, either for any of the reactants or any of the products, you can include that in that form. So an S in parentheses as a subscript means that that substance is in a solid state. An L means it's in a liquid state. A G means it's in a gaseous state. And AQ means aqueous. Oops. AQ means aqueous, which means that it's dissolved in water. It's in a water state. Aqueous comes from, aqua, water, Aquaman, aqueous. That's something we'll spend more time talking about and thinking about later as well. So the thing that this makes possible is that you can actually, another thing you need to be able to do is be able to say what these compounds, say what these reactions are. So like looking at this reaction up here, you wouldn't say Al subscript S in parentheses plus Br2 L in parentheses arrow AlBr3 subscript S in parentheses. That's not how you would say this. You would say the different parts of it. So you would say solid aluminum and liquid bromine react to produce solid aluminum bromide. Here's where all of that work we did for the last week and a half on compound nomenclature for covalent and ionic bonds is going to come in handy, right? AlBr3, you know that that is an ionic compound and it is aluminum bromide. So what I'm going to do is I'm going to stop the video for a moment and I'm going to ask you to go the other direction. From these sentences, write out reaction equations. So pause the video, come back in a few minutes when you're done, and I will show you how it's done. Okay, I am back. The first one, gaseous hydrogen and liquid bromine combine yielding liquid hydrobromic acid. Okay, so first thing is gaseous hydrogen. That's just hydrogen. However, it's actually going to be a 2, and I will explain that in a moment, why there's a 2 there. But that happens to be what it is. So if you just wrote an H, I understand, because I haven't discussed what are called diatomic elements yet. So it's hydrogen, and it's a gas, so I'm going to write a G here. And liquid bromine, so bromine, which is a liquid, which is also going to be a 2. Again, I'll talk about that in just a minute. Combine yielding. So yielding is another way of saying it's producing. So I'm going to draw an arrow here because they combine yielding liquid hydrobromic acid. I should have we didn't cover acid nomenclature yet either, so I apologize. This whole first one is a little bit of a wash. This is hydrogen bromide. Which is another name for hydrobromic acid. So hydrogen bromide. Let's see. Let me think for a second. Bromine has a -1 charge. Hydrogen has a +1 charge. Okay, yeah, so that's going to be hydrogen bromine or hydrobromic acid. And it's a liquid. So there it is. That is the first equation. Gaseous hydrogen and liquid bromine react to form liquid hydrobromic acid. The second one, carbon monoxide gas. Ooh, this is a covalent compound, carbon monoxide. So it's one carbon, one oxygen, and it's a gas. And oxygen gas, so oxygen, it's a gas. Oxygen is also one of these diatomic elements. Again, I'll talk about in this in a minute. Reacts to form carbon dioxide. Ooh, another covalent compound, and it's a gas. So there you go. That's how you write chemical reactions. We're going to have a lot more practice on this in the future. So before I let you go, we've got to talk about diatomic elements because it came up a few times in those practice problems. A lot of elements can just exist by themselves, like sulfur. You can just have a sulfur atom floating around. But there are 7 elements that don't naturally exist by themselves. They often, if you have, like, say, a pure sample of them, instead of just being a bunch of individual atoms of that element, they form diatomic molecules, meaning that 2 atoms of the same element bond together and form pairs. They don't like to be lonely, they like to be in pairs. And those 7 elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So what that means is that anytime that you have these show up in a chemical equation, like in the those last examples, where it says like hydrogen, gaseous hydrogen, liquid bromine, those are both diatomic elements. So when they're by themselves, they're not actually by themselves. They're in a pair of 2. Oxygen is the same way. So basically, you need to remember these 7 diatomic elements. It's something that you just have to memorize so that when they come up in a formula, you know to write a 2 after them instead of just write them by themselves. But I have some good news, which is that when it comes to remembering them or memorizing the 7 diatomic elements, there are 2 different things that you can use to help you out. One is for visual people who remember things like visually and spatially. On the periodic table, all of the diatomic elements make this 7 over here, in addition to hydrogen. So hydrogen is a diatomic element. You're just going to have to remember that. It's all the way over in the left-hand corner. But then other than hydrogen, they all form a 7 on the periodic table, and there are 7 of them. So that's pretty convenient. So if you can just remember where the placement of them is, it makes your life pretty easy. Now, if you're not a visual person, I also have a mnemonic device for you. Remember, I have no bright or clever friends. If you remember that phrase, then you remember the first letter of each of the diatomic elements. I have no bright or clever friends. Iodine, hydrogen, nitrogen, bromine, oxygen, chlorine, fluorine. Just don't say the phrase so many times that you start to believe it, because that would make me very sad. So I just covered a lot of different stuff on this video. I hope that you took notes because this is definitely stuff you're going to need to refer back to and study in preparation for things that we do in the future. So if you haven't taken notes, I recommend going back and writing down some of the most important stuff from this video, especially the diatomic elements. Will really, really come in handy. And I will see you in the next video when we talk about balancing equations. So until then, take care.